Hello again. We're doing sum to product formula problems. Before we did product to sum. Well, now we're doing sum to product. Basically, we're turning a sum, an addition, into a multiplication problem. And it actually gives me an opportunity to present a really cool question that I do to my class. And they like it, although some of them just answer it really quickly and they say, I got this. This is easy, blah, 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 blah. And I ask them, what's the sign of, and we use the first formula because it's the first one that I write down. Now, what's the sign of 90 plus the sine of 30? And they say, well, what do you mean? I'm like, well, A equals 90 degrees, B equals 30 degrees. What's the sine of 90 plus 30? Sine of 90 plus the sine of 30, pardon me. You say, that's the sine of 120, sine of 120 is, root 3 over 2, bam, I'm done. Like, did you try the formula? And they said, well, I don't need to try the formula because, I figured it out. And I said, perhaps your approach, although you thought it was artful, maybe you were a little overzealous. If you plug it into the formula, or at least if you double check your work, you're going to find that perhaps your answer is not what you thought it was going to be. And then, I said, well, what do you mean? Challenging student will say that. And you say, I'll show you. Okay, so the sine of A plus the sine of B is the sine of 90. We're going to go ahead and we're going to substitute in 90 for all our A's and 30 for all our B's for this particular problem, plus the sine of 30 degrees. And that's going to be equal to 2 times the sine of A plus B over 2. Well, A plus B is 120 over 2, so it's actually 60 degrees. And it's going to be the cosine of A subtracted by B, which is 90 minus 30, which is 60, and 60 divided by 2 is 30. And the person will sit there and like, I'm not going to sit there, I'm not going to do all this work because I already know what the answer is. I said, what did you say was the answer again? I said, it's root 3 over 2. I'm like, okay, check that in your calculator, give me a decimal for that. Sine of 90 degrees is actually 1. Sine of 30 degrees is 1/2. 1 plus 1/2 doesn't come out to root 3 over 2, that's 1.5. Root 3 over 2 comes out to 0.86666. So already right there, it's not right. So all of a sudden the student's interest is gauged again. So okay, let me go ahead and see what this problem actually entails. So it's twice the sine of 60. And the sine of 60 is actually root 3 over 2 times the cosine of 30. And the cosine of 30 is root 3 over 2. These are cofunctions and these are complementary angles, therefore they're going to be the same thing anyways. So that's 1.5. Well, let's hope this comes out to 1.5 to say the least. Equals, let's start here. Square root 3 times the square root 3 is 3. 2 times 2 is 4. So this is 2 times, now that was 3 over 4. 2 over 1 times 3 over 4. Here, let me change this up. This is 3 halves. I'm going to rewrite 1.5 to 3 halves. This is 6 over 4. 6 over 4 does reduce to 3 halves. So that actually works. Something that you have to realize about that then. When you're doing sum to product and you're given, the sine of 90 degrees plus the sine of 30 degrees, it's not the sine of 120. It's totally different problem. Sine of 120 is different than the sine of 90 plus the sine of 30 in addition to it. Best example that I can probably give is, that's pretty good actually. Sine of, because I'd be using the same angle, but the sine of 45 degrees plus the sine of 45 degrees is not the sine of 90 degrees because 45 degrees is root 2 over 2, and the sine of 90 degrees is 1, and root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is root 2, which is like 1.414, and 1.414 is not the same thing as 1. So, that's don't get careless, don't get overzealous on this. This is just a basic practical application of this particular problem. Hopefully you found it helpful. With that said, have a good day for now. Goodbye.